Welcome to ClimaScope, one-click climate paired with the World Bank's mapping for results. ClimaScope takes world-class climate change model information from the Community Integrated Assessment System at Tyndall Climate Change Center at the University of East Anglia and merges it with results from the World Bank's mapping for results. The mapping for results platform is built within GeoIQ, as is ClimaScope, making it very easy to federate the two data sets to be able to rapidly look at climate change data and World Bank project information. When you go to the ClimaScope website, it opens in something called the Emission Scenario Explorer. You can pan and zoom simply by dragging the map and either double-clicking on a dark colored area or by using the plus sign. Zoom up to an area of interest. You may need to drag the map a bit to get to exactly where you want to look. Continue to zoom, and you'll actually be able to zoom to the extent where you could see individual roads, parks, or communities. We'll stop here at this level of zoom and look, for example, at what the average annual temperature could be in the 30-year average for 2071 to 2100 for the 9 emission scenarios, the 5 older SRES scenarios of IPCC, and the 4 newer IPCC scenarios. You can also turn on and off layers, such as poverty, in this case headcount poverty percentage by district for Kenya. And then by clicking on the arrows, you can rapidly cursor through both the observed annual average temperature and then the projected annual average temperature for 9 emission scenarios. Turning off the poverty map, you can now turn on the World Bank projects. Click on a project, and in this case you can read information about the project. Go up to the arrows, click on the arrows, and again very rapidly go from the observed temperature through the projected temperature of the 9 emission scenarios. This is a very rapid way of exploring how mitigation options may affect the climate. Temperature and precipitation are available in a given region. Looking at other options, this is a map designed to look at the average climate, annual climate, when the global average temperature reaches 2 degrees C above pre-industrial, normalized across 18 climate models. Again, you can click on a spot, see what the project information is, and then when you click the arrows, you start with observed precipitation, click through the results from 18 climate change models, get to observed temperature, and then click through the results of, again, the same 18 climate models for temperature. So just that fast, one can see how the climate might change precipitation and temperature in any terrestrial spot on the globe. Other featured maps include a 4 degrees C scenario when the global average temperature is 4 degrees C above 1961 to 1990. For water variables, in this case precipitation and wet day frequency for Kenya. Loaded are the Kenya poverty headcount statistics as well as some of the World Bank projects for Kenya. Here you can see information on a project, and by clicking on the arrows you can go through. In this case it's actually fewer climate models reach 4 degrees C by the end of the century, but you can see how the precipitation might change at this spot, as well as the number of wet days, that is, the number of days which receive more than 1 millimeter of precipitation. Moving to other options, there are featured maps for 2 degrees C annual climate for those 8 climate variables. Here we're calling up a map for how the cloud cover could change when the global temperature reaches 2 degrees C above 1961 to 1990 in 18 climate models. So, for example, if you were working on a solar project in the northern Sahara, you would be able to click and see how the cloud cover could possibly change. Here, once you click, you see what the observed percentage cloud cover is, and by clicking you can go through the 18 climate models and see how the cloud cover could change. In this case, all models show a reduction in cloud cover under this 2 degrees C scenario. It's important to look at many different climate models to cover the range of possible uncertainty. Other options include 3 degrees C annual climate, 4 degrees C annual climate, other options within the emissions scenario explorer for temperature, sea surface temperature, and precipitation, and something called the EcoMapper. More information on the EcoMapper is available in the manual, and I'll show you how to reach that a little later. However, the EcoMapper takes advantage of the histograms on the map and sliders. In this case, we're looking at those areas with an annual average sea surface temperature between 10 degrees C and 20 degrees C, both observed and with a global average temperature of 2 degrees C above 1961 to 1990. Those areas that are dark yellow are within that temperature range, both now and at 2 degrees C, while those areas which are lighter either become suitable or become unsuitable over time. And you can click these areas on and off by ticking on the little tick mark. Similar maps are available for EcoMapper Terrestrial, which show both annual average temperature and annual average precipitation. It's important to note that annual average precipitation is per month, so you may very well have to multiply this number by 12 or divide data on, for example, crop suitability by 12 to be able to properly use this tool. In this case, we're looking at all areas with an annual average temperature above 0 degrees C and areas that are fairly dry, just to see where the overlap may be. EcoMapper is designed primarily to use with data such as the FAO EcoCrop data, where you want to look at where do you have suitable temperature and precipitation to grow a given crop. However, in this case, you can look at the areas which are dry and above freezing. Those areas that are both blue and red are suitable within this temperature and precipitation range, while those areas that are just blue are only suitable for precipitation but not temperature. And in this case, you can click and see that it's suitable for both temperature and precipitation, and here it's suitable for temperature but not for precipitation. So you actually have a tremendous amount of options. Moving over to Find Maps, by registering and logging on, you actually get access to these 18 climate models, these 8 climate variables, these 9 emission scenarios, the older SRES and the newer RCPs, 10 different carbon cycles, so looking at the 10 carbon cycles with the 18 GCMs gives you a range of 180 possibilities, 12 individual months, annual or seasons, and a range of time periods. Here we've selected maximum temperature in August for the end of the century for HAD CM3, and you can click on any point and see what the temperature is projected to be at that point. If you look in the upper right hand side of the map, you'll see download this data. These are the recommended citations we ask you to use should you use the data. You can download as GeoTIFFs or in ASCII format. There is a how to use section with a manual that you can download. There will be more videos. And finally, there's an About ClimaScope that gives the basics. So this makes it for a very easy way to see a lot of information on a lot of climate models over low bandwidth, all